Hi everyone, and welcome to the Lesson 6-1 Key Features of Graphs video. To start off with some vocabulary, I believe you've heard these terms before in your science class, but in case you forgot, an independent variable is the variable for which input values are substituted in. So independent refers to our x, our input. The independent variable you will see on the x-axis. The dependent variable is the variable whose value is determined by the input, also known as the output, the y. We can't have the dependent variable without the input. So you can find the dependent variable on the y-axis. Now, two other vocabulary words. We have continuous data and discrete data. Up to this point, you've seen discrete data. You've seen a couple points plotted, all on their own. Discrete means that the points don't connect. So D for don't, D for discrete. The points don't connect. And we need this sometimes because if we're counting by a variable that can only have whole numbers, such as number of people, we can't connect our points because we can't have fractions of people. We can only have whole numbers of people. So that would be a case where we'd have to have discrete data when we cannot connect because we cannot have fractions. But if we were counting by something that we could have fractions, like time or distance, that's continuous data, we can connect the points. So when the points connect, C for connect and C for continuous. Continuous data is when the points connect. And that's for when we are counting by something like distance or time that can have fraction values. In A, it says use the vertical line test and determine the domain and range. Remember, the vertical line test says I should be able to draw vertical lines through my graph, and every vertical line should touch my graph only one time. And if you notice, this graph passes the vertical line test. Every single vertical line touches the graph at only one point. So this passes the vertical line test, and so it is a function. This is the first time we're finding domain and range for continuous data. Domain is all of my inputs, so we're going to be looking at my x-axis. Our x-axis is horizontal. So in order to find the domain, I have to find the leftmost value on the x-axis and the rightmost value on the x-axis. So the leftmost value on the x-axis is at 0, and the rightmost x value is 1250. And x is in the middle. If you remember earlier in the year, we talked about how closed circles mean that I put a line underneath my inequality sign, and open circles mean I don't have a line. So as you can see, we have closed circles at both the leftmost point and the rightmost point. So I'm going to put lines underneath my inequality signs. That is my domain. You can also write domain by taking the leftmost value and the rightmost value. And if it's a closed circle, you'll use a bracket. And if it's an open circle, we use a parenthesis. So because both of these values have closed circles, we would use brackets for our interval. This is two ways to write domain. Let's try range. So range, we are looking at the y-axis, and I want to know how low does my graph go on the y-axis, and how high does my graph go on the y-axis. I see that I go as low as 10, and it's a closed circle, so I'm going to put a line underneath, and I go as high as 110. And it's also a closed circle, so I'm going to put a line underneath. If I would write this in the other notation, I would use brackets, and it would look like this. Now I want you to notice something. I'm not looking at the labels. I know the labels go from 0 to 1250 and from 0 to 110, but if you notice, your graph doesn't go as low as the labels. Your graph starts at 10. So that means that your lowest y value is 10. Let's talk about some other key features of a graph. The first one being the y-intercept. A y-intercept is the point at which your graph crosses the y-axis. That's why it's called the y-intercept. So if you have a graph, you would want the point where it crosses your y-axis. That's the y-intercept. A relative maximum is a peak in the graph. So whenever you see your graph go up like a roller coaster and make a peak, that is known as a relative maximum. A relative minimum is a valley in the graph. So whenever you see your graph make a dip, that lowest value is a relative minimum. Now the absolute maximum and minimum are just the greatest and lowest y values. So the highest your graph goes is your absolute maximum, and the lowest your graph goes is your absolute minimum. And these can include endpoints. However, relative min and max cannot be at endpoints. And if you think about it, relative max and min cannot be at endpoints because we need to see the graph on both sides. An endpoint is the first and last point of your graph. So for example, right here is an endpoint. Now, I can't tell if that's a relative max or a min because we can't see the rest of the graph. It could keep going up, or it could go down and be a relative maximum. We don't know. And so that's why relative maximum and minimums don't occur at endpoints. They have to occur in the middle of your graph. So we're going to practice this by identifying the key features of the graph we worked on the top page. First question is, what is the y-intercept of the function, and what does it represent? So remember, the y-intercept is the point at which your graph crosses the y-axis. So I look, my y-axis is right here, and I see that my graph crosses right here at 10. So my y-intercept is the point 0, 10. And the other part of the question asked us to determine what it represents. Why is 10 important? Well, let's look back and think about what this graph is telling us. This graph represents a roller coaster, and the x-axis, or the independent variable, is the distance along the track. So as you're going along the track, you reach different heights. Our height is the dependent variable, because depending on where you are along the track, you might be at different heights above the ground. So what this 10 feet represents is at the starting point of the track, before you even started the roller coaster, you are 10 feet off the ground. So this represents the starting height of the roller coaster. Number 2 says identify a relative maximum of the function. Remember, relative maximums are peaks. So we're looking at where are there peaks in this graph. And I see 2. There's a peak right here and a peak right here. So we have 110 or 90. Those are both relative maximums. And for maximum and minimums, you're always talking about the y value. That's why they're off to this. We're talking about the y values for maximums and minimums. Number 3 says identify the absolute maximum of the function, represented by the graph, and interpret its meaning. So absolute maximum means the tallest my graph goes. So I'm going to look. The tallest my graph goes is 110 feet. And if that's my absolute maximum, that means that that's the biggest height the roller coaster reaches. So 110 feet is my absolute maximum, and that is the highest height of the roller coaster. Number 4 says identify a relative minimum. A relative minimum is the point where there's a valley in my graph. So I'm going to scroll back up to my graph, and I see there is one valley right here at 30 feet. And lastly, identify the absolute minimum of the function. The absolute minimum is the lowest my graph goes. So I look, the lowest my graph goes is 10 feet. 10 feet is my absolute minimum, and that represents the lowest height of the roller coaster. And those are your key features of graphs. In this class, we're going to focus mainly on absolute minimums and maximum, as well as y-intercept and domain and range. But it is still important to know what the difference between a relative maximum and minimum and an absolute maximum and minimum. I hope this video helped. Please let me know if you have any questions, and I will see you in class.